At the deepest parts of the ocean, the pressure is almost unimaginable. At the bottom of the Mariana Trench, the water pushes with more than 1,000 times the atmospheric pressure we experience at the surface. And as billionaires now know, that's enough pressure to crush many submarines almost instantaneously. And yet, somehow fish and other animals can live thousands of meters underwater without being crushed. So, how do deep-sea fish survive such extreme pressures? The deeper you travel underwater, the more water there is above you. For roughly every 10 meters you descend, the pressure increases by about 1 atmosphere. At 1,000 meters, that's roughly around 100 atmospheres. And near the bottom of the Mariana Trench, that's over 1,000 atmospheres. But pressure itself isn't necessarily what causes something to collapse. The real problem is a difference in pressure. Think about a submarine. Inside, there's air at relatively low pressures, while the surrounding water is pushing inwards with enormous force. If the hull fails, the pressure difference causes it to implode. Deep-sea fish avoid this problem in a surprisingly simple way. Unlike us, most deep-sea fish have very little compressible gas inside their bodies. Instead, their bodies are mostly made from water-rich tissues and fluids, and liquids are really hard to compress. This means that the pressure inside the fish's body stays close to the pressure of the surrounding ocean. Instead of thousands of atmospheres pushing against an air-filled body, the pressure pushes on the fish from every direction, while the fluids inside push back. There simply isn't a huge pressure difference trying to crush them. Many deep-sea fish even reduce or completely lose gas-filled swim bladders, instead relying on things like watery or gelatinous tissues for buoyancy. But avoiding air pockets is only part of the solution. Extreme pressure can still cause problems inside the cell. It can distort proteins, interfere with enzymes, make cell membranes behave differently. Deep-sea fish have evolved special adaptations to deal with this. Their cell membranes contain high levels of unsaturated fatty acids, which help keep the membranes flexible under extreme pressures. And many deep-sea fish accumulate a molecule called trimethylamine oxide, or TMAO for short. TMAO helps stabilize proteins so they can continue functioning under enormous pressures. Interestingly, scientists have found that fish living deeper generally contain more TMAO. So, the deeper a fish lives, the more extreme its chemistry has to become. And this might actually help explain why fish don't live all the way at the very bottom of the deepest trenches. The deepest a fish has ever been observed to live is 8,300 meters below the surface. Beyond a certain point, adaptations like TMAO may no longer be enough to keep their cells functioning normally. So, deep-sea fish don't survive enormous pressure because they're somehow strong enough to resist it. They survive it because their bodies are built to balance with it. With almost no compressible air, water-filled tissues, flexible cell membranes, and pressure-protecting molecules like TMAO, the pressure inside and outside their bodies remain balanced. To us, the deep ocean is an environment capable of crushing machines. But to these fish, it's simply home.